A ticket just came in from a user saying that their application on a VM keeps hanging periodically. You investigate and find out that there's no real issue with the application, no issue with the network. You've narrowed it down to being something to do with the VM itself. It's going to turn out in the end that this is a very common mistake made by junior administrators related to backups and specifically snapshots and the way snapshots work in ESXi. The topic for this video is snapshot deletion, why it's not really a deletion operation, and what effect that misunderstanding could have on your VMs. A common misconception with snapshots is that they work the same way as copying a file. So we have here my lab VM running Rocky Linux OS, and it's performing reads and writes against the -flat.vmdk file. So this is the actual disk file for the VM. So a lot of people think that if you take a snapshot, all it's doing is making a copy of this disk in its current state and setting it off to the side in case we need it in the future. So they think it works the same way as if you're copying a file on, inside of your operating system. If this were the case, then you'd continue performing reads and writes against the original disk file, and any changes there would be lost if something happened to this disk file, but you'd still have your copy over here to restore from. This actually isn't how snapshots work at all in ESXi. If they did work like this, then you can understand why someone might think that it would be perfectly safe to just delete this copy if you decided that you didn't need it. It's just a delete operation. It's not even going to zero out the space that it took up, and so it should have no effect on the reads and writes taking place on your actual disk file. As I said, this is not how ESXi actually handles snapshots. I've deployed a Rocky Linux VM on my ESXi lab server. It has a 150 gigabyte hard drive. I'm working from a template snapshot that I use. So there's going to be an initial snapshot visible in the screenshots that I share. For the purposes of this demonstration, I'm going to create a new 60 gigabyte file. Looking at the files associated with the VM, we can see that there is a 60 gigabyte snapshot. That confirms that the snapshot is not taking a copy of the entire 150 gigabyte disk, only the 60 gigs that have changed since the previous snapshot. Here's how ESXi actually handles snapshots. So first, it sets the original disk file to read only. So you'll still be able to read from this, but it'll no longer be performing writes on that file. Then it creates a new file called the delta disk file, and all new writes will go to that file. So it won't contain any of the original information in the -flat file. It'll just be the new information that was added after the snapshot was taken. And you can still read from both files, depending on where the data that you're looking for lives. Was it taken prior to the snapshot or after the snapshot? In the correct model for ESXi with snapshots, what happens when you delete the snapshot is it has to actually merge the delta disk back into the original -flat vmdk file. So it has to absorb all of that information prior to actually being able to delete that -delta file. In addition to that, it automatically starts reading and writing back to the original -flat file. So on top of having to consolidate the information, it's also now still writing information to that disk. So now you can understand that this is not a simple deletion. It's actually going to have a lot of impact on that disk, and that's where the stun times come from. Now we take a new snapshot after the creation of the 60 gigabyte file. This is the snapshot that we're going to be deleting for the demonstration. There's a lot going on here, so let me explain this step by step. In the upper right-hand corner, I have a ping going from my management PC to the Rocky Linux VM. It shows both a timestamp and whether or not the ping was successful. Now we're going to delete the snapshot. In the lower right-hand corner is an ongoing timestamp on the actual Linux VM itself. Not long after submitting the request to delete the snapshot, we can see that there's a short stun. We can see that both in the upper right-hand corner, where the pings fail, and in the lower right-hand corner, where there appears to be a time gap between the timestamps that we're producing. This would manifest for the user as the VM hanging. In the lower left-hand corner, we see the actual ESXi GUI, and you can kind of see the progress bar at the bottom there, although it's very small. In the upper left-hand corner, we see the progress of the snapshot deletion by tailing the end of the VMware log associated with that VM. Notice that although we ran a deletion operation from the ESXi GUI, in the actual log file it refers to it as snapshot consolidation progress. This goes back to what we were discussing about this being a merging operation and not a purely deletion operation. The actual file won't be deleted until the consolidation progress is complete. And sure enough, once the deletion process is complete, the log file actually tells us that there has been a stun and gives us the length of time of the stun. Let's take a closer look at that log file. You'll be able to find this in the subfolder on your ESXi host under the name of the VM that you're wanting to investigate. And the information you're looking for will be in vmware.log. Taking a look to find the stun times, we do in fact see that it reports a stun time of about 2.2 seconds. This will manifest for the user as the VM hanging and would definitely be noticeable. There are a few takeaways here. Now that we know that snapshot deletion is actually a merge operation that's going to have a big impact on your disk, we know that we shouldn't delete snapshots during production. You shouldn't be using snapshots as backups, and so you shouldn't have very many snapshots anyway. The scenario that I gave at the beginning of the video was where a junior administrator was using snapshots as backups, taking them periodically and then going through at the beginning of the week and deleting older snapshots. This is not best practice according to Broadcom and just in general when working with snapshots and hypervisors. What you should be doing is using a backup service. These backup services will periodically log into your ESXi or your hypervisor, take a snapshot, copy that over as a backup, and then run a deletion operation against the snapshot on the hypervisor. That way you should theoretically never have more than one snapshot at a time, and it should only exist long enough for the backup to complete. To make certain to give your backup software plenty of time to complete the backup. What will sometimes happen is you set up the backup software to, say, run at 6 o'clock in the morning outside of production hours. That works fine. By the time the backup is complete, it has submitted the deletion operation and the deletion and merge has completed prior to work starting at, say, 8 o'clock in the morning. A few months go by, the production load goes up, the size of the disk increases. Now the backup operation takes 3 or even 4 hours to complete. By the time the backup operation is completed, that's when it's going to submit that deletion request on the ESXi server, meaning now you have a deletion taking place during production hours, which we've just seen the impact of. We used to see this all the time. So don't just schedule your backups to happen outside of production hours. but regularly check to make certain that that backup operation is completing plenty of time prior to production start for the deletion operation to complete. Thank you for watching. I hope that this has been helpful for you. If you'd like any more information about these topics, or if you'd like some personal one-on-one instruction related to ESXi, VMware, snapshots, or a broad variety of other technical topics for technical support, you can find my information at futurerooster.com or send me an email at rooster@futurerooster.com.